Hello and welcome back to the channel. With the recent surge in COVID cases, it's more important than ever to understand how our immune system works. In this video, we'll be exploring the topic of immunity and how it can help protect us from illnesses like COVID-19. Immunity is the body's ability to defend against infections, and the immune system is the defense organization of your body. The immune system is a highly intricate and dynamic system made up of cells, tissues, and organs that work together to protect the body from harmful pathogens and cancer cells. The white blood cells, which include lymphocytes, neutrophils, monocytes, eosinophils, and basophils, have unique roles to play in the immune system. Additionally, the immune system consists of natural killer cells and a variety of tissues and organs, such as the thymus, bone marrow, lymph nodes, spleen, and mucosa-associated lymphoid tissues. The immune response is classified into two types: the innate immunity and the acquired immunity. Innate immunity, also known as natural, native, or non-specific immunity, is the first line of defense that the human body deploys to ward off pathogens. A pathogen is a bacterium, virus, parasite, or fungus that can cause disease within the body. Innate immunity is present from birth and offers immediate protection against a broad range of pathogens. It consists of physical, chemical, and cellular components that work together to recognize and destroy pathogens. Physical barriers, such as the skin and mucous membranes, prevent pathogens from entering the body, while chemical barriers such as stomach acid and enzymes aid in pathogen destruction. The cellular components of innate immunity include various types of white blood cells that recognize and destroy pathogens directly or indirectly by releasing chemicals that attract other immune cells to the site of infection. The innate immune response is slow and non-specific, which means it produces the same response to all kinds of pathogens and cannot differentiate among them. Hence, many pathogens have evolved to resist innate immunity, and protection against these infections requires the more specialized and powerful mechanisms of acquired immunity. Acquired immunity, also known as adaptive or specific immunity, is the type of immunity that develops after the body is exposed to a specific pathogen. Unlike innate immunity, acquired immunity can selectively target specific pathogens and has the ability to recognize a diverse range of foreign substances, making it more effective in defending against previously encountered pathogens. There are two types of adaptive immunity: humoral immunity, which is mediated by soluble proteins called antibodies that are produced by B lymphocytes, also called B cells, and cell-mediated or cellular immunity is mediated by T lymphocytes, also called T cells. Antibodies produced by the B cells protect against extracellular pathogens in the blood, mucosal surfaces, and tissues. Meanwhile, T lymphocytes are important in the defense against intracellular microbes. When a pathogen enters the host's body, the innate immune system uses pattern recognition receptors found on the surface of immune cells to detect pathogens. Pattern recognition receptors, or PRRs, recognize specific structures found on the pathogen's surface, known as pathogen-associated molecular patterns, or PAMPs. Once the pattern recognition receptors on the surface of innate immune cells recognize the pathogen-associated molecular patterns, they trigger an immune response that leads to inflammation. Inflammation is an important part of the innate immune response, as it helps contain the pathogen and prevent its spread to other parts of the body. After the innate immune system recognizes the pathogen, immune cells such as dendritic cells capture pieces of the pathogen, known as antigens. Typically, each pathogen has unique parts that are responsible for causing the disease associated with it. The part of a pathogen that prompts the production of antibodies is referred to as an antigen. These antigens are then presented on the surface of dendritic cells to activate adaptive immune cells such as T cells and B cells. This process is called antigen presentation and is a critical step in the adaptive immune response. The adaptive immune response then activates the B and T cells that can recognize and respond to specific antigens on the pathogen. B cells produce antibodies that bind to the antigen and mark the pathogen for destruction by other immune cells. You can consider antibodies as the soldiers in your body's defense system. Each antibody in the system is specifically trained to recognize a particular antigen. Our bodies have thousands of different antibodies. When the human body is first exposed to an antigen, it takes time for the immune system to react and generate antibodies tailored to that specific antigen. The T cells help coordinate the immune response by releasing cytokines, which are soluble proteins that activate other immune cells or directly kill infected cells. The combined efforts of B and T cells provide a specific and highly targeted immune response to eliminate the pathogen. Once the pathogen has been neutralized and destroyed, the body eliminates the remnants and debris of the pathogen. The lymphatic system helps to clear away any remaining pathogens or debris by draining excess fluid from the tissues and returning it to the bloodstream for filtering by the kidneys and liver. The body may also eliminate remnants of the pathogen through bodily fluids such as urine or feces. The immune system then returns to a state of rest, ready to respond to any future pathogen threats. When the body produces antibodies as its primary response to an antigen, it also creates antibody-producing memory cells. These memory cells remain in the body even after the pathogen is eliminated. If the body is exposed to the same pathogen again, the memory cells are activated, resulting in a faster and more effective immune response due to the pre-existing antibodies. This is the principle behind immunization, where exposure to weakened or dead pathogens or specific parts of the pathogen, known as vaccines, stimulates the immune response to create memory cells without causing disease. However, sometimes the immune system can overreact or fail to respond effectively, leading to autoimmune diseases or infections that can become chronic or even life-threatening. In autoimmune diseases, the immune system mistakenly attacks the body's own cells and tissues, leading to tissue damage and dysfunction. Infections that become chronic can persist despite the immune system's efforts to eliminate them, leading to ongoing inflammation and tissue damage, for example, in the case of cancer or HIV/AIDS. I hope you found this video informative and helpful in understanding how our immune system works. Remember, taking care of our immune system is crucial, especially during these challenging times. By eating a healthy diet, getting enough sleep, and staying active, we can help our immune system fight off diseases and keep us healthy. If you have any questions or comments, feel free to leave them down below. Don't forget to like the video and subscribe to the channel for more informative videos like this. Thanks for watching, stay safe and take care.